Retro.
Yeah.
Electro. Tech.
Oh yeah.
Hey, turn the lights back on. Wow. Retro Electro Tech. When real audio ruled the world.
Well, hello there once again, ladies and gentlemen. This is Retro Ernest of Retro Electro Tech. And here on the bench is an Onkyo Integra model M504 stereo power amplifier made in 1987, I believe, and had a production run from its date of birth to about 1997, so about a 10-year run based on the information I was able to obtain, although I didn't do a lot of research, so I can't vouch for the accuracy of that, but sounds about right. You know, I remember these, in the late 80s, 90s, and all that, so sounds about right. Okay, so in getting started on both of these, including the Onkyo P as in Papa 304 preamp and the main amp, I need to perform a preliminary evaluation, and the customer requested that I go into detail and really look these over with a fine-tooth comb. So that's what I'm going to do. I obviously started with the exterior when these units first came in. Made sure everything looked normal. So it starts with looking at the equipment when you get it in. Make sure that there's nothing odd, nothing atypical about the exterior. Then, of course, as mentioned, I'm going to pop the hoods on both of these, take the covers off, and perform a preliminary evaluation which entails inspection using, using a light and a magnifier. I go through, it's pretty typical for me to do that. I'll get back in and perform some more inspections, a little bit more up close and personal, just to make sure I didn't miss anything the first time around. And yes, I actually do the work. I will go in and do that because I want to be sure that I didn't miss anything, because if at all humanly possible, I don't want this stuff coming back to me if it could be avoided. So I'm going to go through and look for obvious things. Is there any damage to any of the components? Are electrolytic capacitors bulging at the vents? Are they leaking around the bases? Is there electrolyte on the circuit board? Does anything look heat stressed, overheated, discolored? Anything look cracked? Sometimes you can't see the cracks from a distance. You got to get in a little tighter and look at things a little bit better. Look for signs of cracking on the case or whatever. Look for any connectors, like pin and socket connectors, that might be present, that might be defective, that might look dirty, tarnished, oxidized. Does the wiring look like it's intact? Does the wiring look compromised? The insulation look compromised? Does the insulation look, cut or abraded, otherwise charred, damaged, whatever? So you want to really go through and look for physical signs of problems, things that you can see right off the bat. Any damaged components, anything that looks off, anything that looks atypical. So I will do that by going in with my light, my magnifier, check things out to the best of my ability with the time that I have to work at that moment. So I want to look for obvious stuff before I perform a safe power up. Okay? So let me move on from there and talk about that, safe power up, because I'm going to be getting into a little bit more when I go in and do the actual preliminary evaluation, start inspecting things. I'm going to take you guys in on that and just sort of look around here. So when it does get to the point, though, that I'm satisfied that everything's looking good physically, then I'm going to get to that safe power up phase, and that just means using equipment that assures I'm powering up that equipment as safe as possible, so it minimizes any risk of that equipment failing in a catastrophic manner and causing damage to the equipment or damage to the tech. It makes it safer for the tech, but it's the tech's job to use his or her brain and assure their safety. Number one, with their brain. You know, their brain is the number one piece of safety equipment, number one piece of test equipment, diagnostic equipment. But I'll talk about that later. So we're going to do everything possible to assure that this is brought up safely with the appropriate safety equipment. And at that point, when everything is looking good, if everything remains stable, that's when I'll get into some performance testing of the amplifier. And I'll talk about that more when the time comes. Okay, so right now I'm not going to talk about that. I'm just going to kind of get to it here and get ready to go through the motions of getting to that point where I start performance testing this amp. Because once I have a clear picture of what's going on, what it needs, and what I'm going to recommend, then I'll know at that point what I'm going to be getting into, of course, if the customer wants me to move forward with said recommendations and all that. So let's go ahead and get to it. Okay, and here we are looking into the top side innards, starting with the power plant, the power supply. So you can see this is a dual power supply setup. We have our two power transformers, okay? And we have our rectification board here, our two bridge rectifiers. The only thing that I've done besides popping off the top is removing this guard here, okay, that guards the fuses. Anyways, from what I can see, the fuses look okay. I can see the elements of the fuses. They look to be intact, but I'm going to just pull them out real quick and check them. I just mainly want to check to see if the correct ratings are in place. We should have a couple of 6 amp 125 volt fuses, and I just want to check them out real quick. Matter of fact, let me bring my magnifier in place because my eyes aren't what they used to be, but then again, they're not the worst they could be either. I at least have my eyesight. 6 amps, 125 volts, this fuse here. And let me grab the other one real quick and just check it out. And this one is also a 6 amp, 125 volt fuse. And remember, this amp is a working unit. So, I'm sure the fuses are fine, but I don't want to get complacent. I'm going to check them anyways. Let me turn on my continuity tester here. And, all right. So, let's make sure. Yep, looking good. All right, so these fuses are intact, the correct ratings. All right. So what else am I looking for here? Well, obvious stuff. Again, how's all this wiring doing? Is this wiring looking all right? We want to go in here and check that stuff out. And I can only see down so far. Of course, as I go through in more detail, I'm going to check everything out the best that I can with the time I have to work with. So again, just going through the wiring, making sure that the insulation isn't compromised anywhere, that I can visually make heads or tails of. And from what I can see, yeah, everything on these surfaces here, all this wiring throughout, associated with this power supply section here, everything looks good. Everything looks intact. The insulation, nothing's cut, abraded, charred. The circuit boards look good. Other than some layers of dust, there doesn't look to be any discoloration, any signs of getting hot. The bridge rectifiers, the cases look good. They don't look cracked. They don't look discolored. They don't look like they've been getting extremely hot or anything like that. the transformers, including these chokes. Underneath these circuit boards, there's some chokes down here. The chokes look to be in good shape. These transformers look good. There doesn't appear to be any signs of arcing or anything like that. Everything looks really clean in here. You know, it looks like it's been operating at an acceptable temperature or within an acceptable temperature range. Everything looks good. So that's the main thing I want to take a look at right off the bat. Okay, so we're good there. And now if we pan up just a little bit, we have here our two heat sinks for both channels. We have our cluster of filter caps here, our main reservoir caps. And then, you know, we have our main amp sections, our boards here. And these are areas that I'm going to pay some attention to because I want to move throughout and spot check resistors, diodes, transistors, drivers, pre-drivers, all that stuff. I'm going to go in and spot check with a meter in diode mode. I'll probably just go through and just check junctions real quick. I'm not hunting down an active problem. So my main objective is just to go through and spot check. And a lot of times when I'm going through just with, you know, a meter and a couple probes and just kind of, it gets my attention honed in on the various components that I'm spot checking. Like resistors, I'm going in and checking the values of resistors to make sure that none of these resistors are way out of tolerance or starting to drift in that direction. So it puts my attention on the component as I go through and spot check them. Now with resistors and transistors and all that, like I said, I'm just going through spot checking. And if I get a really weird anomalous reading, then I'll pull it from circuit and check it out of circuit. But other than that, I'm just going to go through. I'm just interested in the behavior of the transistor junctions and diode function, and again, resistor values. I want to check connection points like pin and socket connectors, like you see these cables here. You see the type of connectors that I'm referring to. So we have our relays on this board. This is our relay board. So I want to get in there and be able to check the contacts. I want to look for dirty contacts, any pitting, stuff like that. If the contacts are in good shape on these relays, all I will have to do is buff them out, a little bit of solvent on a swab, whether I use anhydrous alcohol or a contact cleaner, go in there and just buff out the contacts. But if they're in rough shape and they're pitted and all that, then I'll of course look into replacing them. So I will be checking the relays as a matter of course, because that's important to do. Make sure that our relays are in good shape. And like I said, spot check all these components, connectors, connect all the connection points, check out these ribbon cables. So I really am going to do the work and do a good once over before I even power this up. So let me go ahead and just kind of move through and get into that a little bit more. Okay, so we're looking at the underbelly, and let me just pan down and back up, show you how everything looks under here. Not a lot to see, but anyways, if I replace the reservoir caps, which ideally I like to do when I can, this can complicate things a little bit. It just adds more to the equation when it comes to being able to work within a certain footprint without dealing with modification and all that. But along with that, I have to give consideration again to the size of the caps, the lead spacing, and whether or not all that is going to work within this footprint here without going into modification, which I don't want to do unless there's no other way around it and it's absolutely necessary. The first thing I'm going to do is individually test each of these reservoir caps. I'm going to take a good look at capacitance, ESR, and definitely leakage. And collectively, if all of those come together well, and the health of these caps is such that all those characteristics, are coming together, they're looking good, they're still looking strong, well then I may decide not to replace the reservoirs. All right, so what are we doing here now? Well, what we're looking at here is the back of the relay board, okay, the protection board. You can see our cables in the back there feeding the board here, which is, let me pan up, okay, our binding posts there, our speaker terminals. Okay, so of course we're going to really want to do our due diligence and check these solder joints on the back of the board, all these connection points, ribbon cables, all these connection points involving the relays and all that, because although the entire metropolis of solder joints and components throughout this entire amp, throughout various pieces of equipment, all of it is important, yes, but especially in these areas here, if we start having connection issues going on, well, the customer will end up, losing signal, intermittent behavior, lose a channel, one channel, both channels, whatever. So we want to make sure that everything is looking good on these boards especially. And anywhere where I have access, that's exactly what I'm going to do. So let me go ahead and zoom in a little bit, get my magnifier, and show all of you what I'm looking at. Let me drop my exposure down. All right, I think that probably looks all right. And let me go ahead and adjust this a little bit. I think that's good. So when I'm going through evaluating connections, because connections are a big contributor to problems in all of this vintage gear. So I'm looking for things like good solder joints, of course. And what makes up a good solder joint? Well, notice the shape of all of these solder joints, regardless of the size, okay? These larger solder joints, we're looking for uniformity and that nice conical shape. Okay, look at the conical shape of all these solder joints. If we look at the texture of these solder joints, we don't want to see anything that looks really pitted, cracked, anything that looks like there's rings around the especially around the base of these solder joints. Sometimes you'll see rings like cratering. It looks like the solder joint is kind of collapsing in on itself, kind of collapsing into the through hole. Okay, so if you see anything that looks like it's, any of these joints that look like they're cratering, they look cracked, webbed, whatever, kind of pitted, blotchy, or just the shape of the solder joint looks kind of gnarly, kind of bulbous, and kind of blotchy. In other words, it just looks substandard. In other words, whereas these solder joints here all look good actually. From what I can see here, all of these solder joints, especially again, involving these ribbon cables that are feeding the board and so forth. Check out the backside of the connectors, these solder joints. Check all the connectors. Make sure everything's tight. And again, there's a lot of issues with solder joints and connectors and all that throughout all of this equipment. A lot of the problems I see are on account of that. So everything's looking good here. Yeah, there's some residual, flux, and there's this glue. They glued down these jumper wires and all that. But everything else looks pretty clean, looks pretty good. So do your due diligence and check that kind of stuff out. Make sure that everything is looking good there. Let me get the exposure back up here real quick. I think that'll do. So what I'm going to do next is I'm going to flip this unit over, and so I could look at the solder joints a little bit better on the back of this board. Probably not going to do that on camera, not really necessary. Plus, like I said, I just want to get through. So yeah, let me go ahead and do that, and then I'll come on back and and touch on another topic. Okay, so I'm back on the bottom side. I wanted to get these copper plates out of the way of this board so I can have clearer access to the leads extending from each filter cap from the top side, of course. You can see each cap sports 4 leads, 2 per side, negative and positive. So 4 leads popping through, and that's, you know, what the circuit board design supports. You know, that's how they designed it to be, and that's what makes matters a bit more complex if I want to recap these filters. Now, if I absolutely have to do it, then I'll do it, which is going to involve modification for sure. But I'm hoping that as I go through and test capacitance, ESR, leakage, that everything's going to be within specs, so I can leave well enough alone, just you know, cobble everything back together, you know, all this. That's, you know, that's made more complex than it needs to be. That's going to be enough, you know, work as it is. But it's better than having to try to modify the circuit board because of lead spacing issues, footprint issues, you know, not finding a replacement that has the right lead type / lead style that's going to work with this circuit board layout, and, you know, their copper plates that, you know, solder in and tie everything together in addition to, yeah, everything else. So, you know, but we'll see when I cross that bridge. Again, if I absolutely have to do it, I will, but I'm hoping for the customer's sake and mine that it's not, because it's going to get time consuming if I have to modify the board, mess around, and, you know, hunt around for the capacitor replacements that will get me as close as possible to being able to make everything work with the minimal amount of modification and all that jazz. So let's just hope, and that's really about it. You know, because otherwise, if it was just a normal capacitor bank layout that is just pretty easy to, you know, pop the old ones out, pop the new ones in, then everything would be great. You know, we could all just drink good beer, sing happy songs, and dance around the campfire and all that, but that's not the case here. So anyways, I'm going to go ahead and get to it. I'm going to pull these caps out and start testing and keep my fingers crossed that everything is going to be within tolerance. So anyways, let me get to it and I'll be right back. Okay, so I'm going to briefly point out what I'm doing here. I'm not going to take much time doing that because I have to move on. So I'm obviously not going to be testing every cap on camera, but I'm going to go through that that capacitor bank and the power supply, the reservoir / filter caps, and do what I'm doing here. Of course, I'm going to do some capacitance testing, ESR testing, and then leakage testing, which is the phase I'm in right now. And nothing fancy going on here. No need to get fancy with doing a proper leakage test that's applicable to working on this equipment here. This isn't going into orbit. It's just a stereo amplifier. So we're just checking some old capacitor cans, and again, I have these brought up to their working voltage via a regulated power supply. I have the DMM tied into circuit. Nothing fancy there. This is an old school method that, you know, people have been doing for ages. So there's information out there on how to do that. It's not a big mystery. So I just have the DMM tied into circuit, and I'm monitoring the leakage current. You can see I have about 1.2627. It's bouncing around a little bit, but it's pretty much settled off where it is. So things are looking good. Low leakage current for this cap here, and I'm going to rinse and repeat on the other ones. If I'm in the same ballpark, more or less, with leakage, ESR, and capacitance, then looking good. I'm going to come back if that's the case and just briefly go over the averages of all the caps, mainly for the customer, to let them know, yeah, pass, fail, pretty good. Could a cap still fail down the road? Sure, they're old caps. But if everything is looking good in terms of their leakage ESR and capacitance, then more than likely they're going to hang on for a while. So that's what I want to establish, rather than going through and trying to shotgun recap this whole capacitor bank, because of what I explained earlier with the way they're laid out and the way that Onkyo kind of overcomplicated the whole situation of mounting these caps in. Again, you know, this is a good amp. It's a solid amp that was put together well, but in my opinion, they just overcomplicated that whole situation with the power supply bank and made it really tough to, you know, go through and recap. So anyways, let me go ahead and get back to what I'm doing with testing these, and then I'll come back when the verdict is in on the health of all of these caps and the power supply there. Okay, so I'm done testing the filters. Got everything mounted back in place on the back side, you know, that complex mounting array that Onkyo over-engineered. But nonetheless, I am happy to report that everything is testing within spec. And for example, the individual readings leakage-wise was between 1.3 and 2.5 microamps at full voltage, working voltage, so that's good. These are 9,000 mics at 80 working volts, and all of these caps tested within a range of 7,300 to 7,700 mics, all of them. So all of them were within that range. Yes, they are reading lower than 9,000 mics, but that's not horribly uncommon. And being that all of them are reading within that 7,300 to 7,700 mic range, and that range is within 20%, we're looking good, okay? Everything seems to be doing what it's supposed to be doing. ESR, 0.00 to 0.01. So the ESR is nice and low. So cumulatively, okay, if you look at that big picture and put all that data together, all those parameters are pointing to the fact that these do not look like they're going to fail anytime soon. Now, as I always say, that doesn't mean they cannot fail or will not fail, but it looks like there's nothing imminent going on. And because all of the readings together, all of the parameters together, again, leakage, capacitance, and ESR are within spec, I think everything is going to be just fine, okay? Now, because of their age, yes, they can, you know, one or more, whatever, can take kind of a fast turn downhill and start to show higher leakage, high ESR, you know, all that stuff. But I kind of don't think that's going to happen anytime soon. So that's good. We dodged a bullet there because, like I said, being able to find replacements or substitutes that, you know, mount up within this tray here that they're sitting in, you know, with the right lead spacing, the right lead type to work with that mounting array on the bottom, you know, the board, the way the board's set up, and those copper plates and all that stuff. Yeah, it's really a chore. Anyways, enough of that. I'm going to move on from here. What I am going to do is get with the customer, send him the link to the video once it's wrapped up, talk to him again about getting the rest of the caps, especially in the amplifier section here, and, you know, whatever else I could get out and I have access to, get them out and pop them in. There's nothing special going on with the rest of these small electrolytics in here. You know, desolder them, pop them out, pop the new ones back in. There's no complex over-engineered mounting array going on. So good to go. So we'll, if the customer gives me the green light, we'll get all these caps squared away, you know, the rest of them, leave these in place. But I at least wanted to go through the work that it took, the time that it took to assure that we had a good heartbeat, you know, that these filter caps in the power supply, these main filter caps, were looking good, because we've got to have a good power supply. You know, it's literally the heart of the unit. So that's why I went through the trouble. And I went through the trouble because I just wasn't able to shotgun them, pull out the old ones, pop in new ones. again, without going through a big ordeal. Okay, and now before I move on and get this information passed to the customer and of course get the green light to start the work that I want to do that I already mentioned, I wanted to safely power this up, and I did. I performed a safe power up, not a single hiccup. And for the customer, what a safe power up is just that. I'm powering up your amplifier in a limited current state so that if something was to go wrong, try to go wrong, the current would be limited to the device under test here, starved of current. The current that it would normally need to go into a catastrophic failure type of situation, shorting out, going into meltdown mode and all that. So the device that I had it plugged into initially up there on the rack there, a current limiter, does just that. It starves it of current, and there you go. So everything looked good. It passed with flying colors and all good. So I have it off the current limiter now, idling here, and I'm just about to set the biasing. That's what these 2 meters off to the side are reading right now, is the bias voltage, and I'll talk about that in just a moment, very briefly. Okay, so as far as the bias is concerned, I'm going to explain just briefly for the customer what that entails and why I want to establish a baseline as far as where the bias is sitting, and then go in and just do a baseline adjustment. Why do I want to do that? It's because the importance of biasing is that the transistors in the amplifier section, when the amp is at idle, need to be set according to factory spec, which in this case is 15 millivolts. You can see over here the left channel is hovering at about 9.9, 10 millivolts, whatever, and the right channel 16.4 millivolts. So, you know, the right side is a little on the low side, left side's a little bit higher. Not a big deal, but I'm going to get inside with a screwdriver here. There's some VRs, some trimmers that are adjustable that I'm going to tweak so that I can level off the bias voltage and get them where factory spec indicates. And why that is those transistors in the amp section, during idle, they need to be set in a partially on state. Okay, so they're partially turned on, kind of revved up and ready to go. They have a bias signal applied to them, so that when the amp receives a signal at its input, and it's ready to pass signal, it can do so efficiently. And to do that efficiently, it needs to be operating in what's referred to as the linear region. We want the input signal and the output signal to be the same. We don't want a deviation in terms of frequency response that would negatively impact the sonic characteristic of the amp, bring about distortion and all that. So we want this operating in that linear region. Again, the signal coming in is the same as the signal going out. Of course, the signal going out is amplified, but we want that good, clean signal. And we achieve that, in part anyways, by assuring that the transistors are biased properly and in that partially on state so that they can, again, efficiently pass signal. So there you go. That's, there's more to it than that, but that's a simple explanation. So I'm going to do that. Oh, and by the way, I checked DC offset at your speaker terminals. DC offset is just that. We don't want DC on the speaker terminals. Any elevated DC present at the speaker terminals could result in burning up your speaker's voice coils. So that's stuff that we always want to check for. But there was no DC on your speaker terminals, and I just checked that with the meter at the speaker terminals. So otherwise, I'm going to go in here and tweak the the bias voltage, like I said, and get that around that 15 millivolt range. And then after I do the work that I'm going to do in here, then I'll go back and check the biasing again. If I need to tweak it again, I will, and get everything dialed in just so. Also too, I have the preamp here that I still have to do, this P304 preamp by Onkyo, of course. So I'm going to be working on that as well. I still need to get in that and go over the same type of evaluation that I did in the main amp here. So there you go. So I'm going to get on with it, and I will be right back. Okay, so everything went well, setting the bias, it held stable. I have a signal piped into the amp right now. I'm monitoring the outputs, as you can see there. Both channels are symmetrical. They look clean, the waveforms look clean. Everything's nice and stable, not a single hiccup. I didn't figure there would be. Like I said, it's a good working amp. So yeah, I've been monitoring things for a little over an hour now, something like that. I at least wanted to do that in the meantime. Like I said, I still have more work to do on the main amp and the preamp. Once I get that done, then I will go into some performance testing, get more in depth there, audio testing as well. One thing before I close this out is I wanted to mention that the lamp is out on this meter here. I don't know if it was the customer may have mentioned that to me. So I'm going to end up relamping this. I'll probably just obviously do both sides, freshen things up, put some new lamps in there, call it good. And but that's going to come later. I have other stuff to do, bigger fish to fry overall. So I'm going to continue monitoring things. Like I said, I'll get with the customer and see what's going on and get the work done that I need to get done. And other than that, yeah, I think that's about it for now. I wanted to break this up into a few videos, which is what I'm going to do. I didn't want to do the evaluation of the preamp, you know, with this video, you know, or in this video, because it would have been way too long. So otherwise, I'm going to end it here. As I always say, guys, peace, love, music, and the vintage audio that brings it to your ears. Till next time, y'all take care.
This is a poor man's shoe production.